boys and girls. This is a video on compositions of functions. This goes with section 7.3 in your Algebra 2 textbook. As it says on the board here, after this lesson you should understand compositions of functions and be able to compose functions. So let's just talk really quickly about what a composition is not. Well, it's not any of the things we've done before as far as adding or subtracting or multiplying functions. It's not even dividing functions. Essentially what it is, it's doing one function and then another function. So doing one function and then another. And maybe you're even doing more than that. Maybe you're doing 3 or 4 functions. We're going to probably stick with 2, or I'll give you a fun one at the end where you can have 3, maybe even 4 compositions to do. But basically, it's just doing one thing and then another, not necessarily adding or subtracting or multiplying or dividing any of those things. So you've actually probably seen something like this. Imagine you went to a store where you had a sale that was 25% off. And then you get to the front, and they say, okay, you're going to take an extra 10% off. So that's doing one thing and then another. That's doing a 25% off and then a 10% off sale. And believe it or not, this is actually not 35% off. So we'll see at the end what's actually happening here, but you'll see that this is actually not a 35% sale. That would be something different. Okay, so as I said, composing functions is just another way of combining them. That's all it really is. So we write it in one of 2 ways. So here's the formal way of looking at this. We can say f of g of x. In fact, I'm even going to change my colors here so this looks a little nicer. And that's the same thing as saying this. And this notation does not look nearly as nice. I tend not to use this notation. But you may come across this, so I might as well just throw it at you. But we're going to stick with this first one here, because this one really does the job and explains it a lot better. So when you look at it like this, you can see that the function g is inside the function f. So that's analogous to doing this. I'll add my little function machines over here. This is kind of like, and I'm just going to make up some numbers. I'm going to pass them through my functions. I'm not going to tell you what they are. You can even make up your own functions for this. But let's say we put the number 2 into g. So what comes out is, let's say it's 5. So in other words, g of 2 is 5. Well, according to this notation up here, I now take the output from g, which is 5, and I put that into f. And what's going to come out is something else, and I'll just say what comes out is 12. And so what we could say about this then is f of g of 2 is 12. So this says take 2, put it into g. Whatever comes out of that, put that into f. So you're really just working inside out to get the composition here. But anyways, this is how we write it, f of g of x. And this says specifically to do just that. Take your input, put it into g, take that and put that into f. If I write this the other way around, let me get this out of our way here. If I write it like this, g of f of x. This is saying do something else. This is saying take x, put it into f first, and then take that and put that into g. Let's see what happens if I find g of f of 2. So let me get some of the stuff out of the way. I'm going to find g of f of 2. And of course, I can't do this because I actually don't have these functions. So I'm actually going to skip this problem and move on to something else here. Sorry about that, folks. Okay, so let's look at some actual functions here, and we'll do some evaluating. So we're going to use the following functions to evaluate each of these things, a, b, c, d, and e, all along here. And my f function is going to be x squared plus 4. My g function is going to be x minus 3. And again, I'm going to use as a prop, I'm going to use my little function boxes here to kind of help us out and see what's going on here. So let's take a look at what A is telling us. A says take 5, put it into g. Well, as far as my picture goes, that's saying do this. I'm going to take 5, I'm going to put it into G. G says to do what? Well, G says to do x minus 3. So take my input, 3. Take my input 5, do 5 minus 3. What comes out is going to be 2, right? So whatever comes out of that is going to go into F. Well, what does F tell me to do? F says do x squared plus 4. So I'm going to take 2, I'm going to square it and add 4. Well, 2 squared is 4, 4 plus 4 is 8, so what comes out of this is 8. So f of g of 5 then, when I take 5, put it into g, I take that output, put it into f, I get back 8. So that's how we do this process. Let's do b together here. And again, I'm going to use these function boxes as props, just to kind of help us out with the idea of what's actually going on here. So when I look at b, this tells me to put 5 into f. Okay, so I'm going to line these up so that f comes first, and then g is going to go second after that. So I'm going to put 5 into f, and again, f is my blue function, so that tells me to do x squared plus 4. So I put in 5, I square it, and I add 4. What pops out is 29. And I put that into g. And g is my function that says do x minus 3. So I put in 29, I do 29 minus 3. What pops out then is going to be 26. So I get g of f of 5, or if I put 5 into f first, put that into g, what pops out is 26. So notice how we get different things. In other words, it matters which order we do this in, right? I'm starting with the number 5 in both cases, but in my first case, I went through G first and then through F. In my second case, I reversed the order and I got different values here. And that's often the case that we're going to get different things depending on which order we do things in. Okay, so for C, I'm not going to use the props anymore. I'm just going to go ahead and use my functions that I have up here. So let's take a look at what C is saying. This says put 2 into G first. Okay, so G of 2 is 2 minus 3. That's negative 1. So I can rewrite this if I want and say that G of 2 is negative 1. Well, now this just says take negative 1 and put it into G again. So I'm going to do negative 1 minus 3, and I'm going to get negative 4. So I can do the same thing with my function boxes over here. I just don't have another function box that says G. But you should also you want to kind of get away from using the function boxes all the time. So I invite you to use these for a little while, but then you got to ditch them eventually here. Okay, let's take a look at D, and we'll take a look at E. What D is, if you notice, we're taking X and we're putting it into G. Well, this is actually kind of nice because we know what G of X is, right? G of X is actually the function that we have up here, right? Here's G of X right here. So I'm going to take, let's see, G of X, I'm just going to rewrite that, and that's going to be X minus 3. And now here's what this is telling me to do. This is telling me to take X minus 3 and put it into F. So this is like saying find F of X minus 3. Well, I can do that, right? Because my F function just says take something and square whatever your input is and add 4. So my input is X minus 3. I'm going to square that. That's square, double square. So X squared minus 6X plus 9. Plus that original 4 that was hanging out there. So I can say that F of G of X equals X squared minus 6X plus 13. So what we've just done with this is actually kind of nice. Let's get that boy out of the way here. This is now a shortcut, if I want, F of G of X, for finding something like what I did up here in the first problem, where I found F of G of 5. So what I should be able to do now is I should be able to plug 5 into there and get the same answer that I got before, which was 8. So let's see if this works. F of G of 5 is going to be 5 squared minus 6 times 5 plus 13. So we get 25 minus 30 is negative 5, plus 13 is, whew, it worked out. I got 8, just like I got way back up here. I got 8 when I did the long way, right? I did it one piece at a time. But this gives me a shortcut, which really is the power of algebra, that we can combine functions together in this way, and really kind of gives us a shortcut rather than doing one function and then another function. So let's do this last one here. As far as I'm jumping all over the page here, but I apologize. And now I'm going to combine my functions, and I'm actually going to get a lot of, clean all this up. It's all in my way here. And I just need to see what my functions are up top. So this says, take my function f of x, and I'm going to put that into g. So g says, take my input and then minus 3. Okay, well my input is all of f, right? All of f is going into g. So here's f up here, x squared plus 4. And so what I get out of this then, my combination, my composition, g of f of x is going to be x squared plus 1. And again, and I already erased it, but if you went back and you plugged in our input for g of f of 5, I think we end up at 26. So if I do g of f of 5 with my shortcut here, I get 5 squared plus 1, which, yeah, indeed, is 26, just like we had before. So again, it gives us a shortcut from doing one function and then another. Okay, let's bring this all the way back to what we did in the beginning, and let's talk about a sale problem. So let's say you go to your favorite store, whatever your favorite store is. I like Kohl's, because they have nice clothes, and it's not expensive. Anyways, that's my little plug for Kohl's. So anyways, they're having a 25% sale, and then when you get there, you find out that you get to take an additional 10% off. So I contend that this is actually not a 35% sale, and we're going to see this with our composition of functions. So first thing we're going to do is we're going to compose these into a single function so that we can get the sale price of the item. So it's a little, these are always a little tricky because, yeah, it's a 25% sale, but what percent are you actually paying? Well, you're paying 75%, right? Okay. So our first function, I'm going to call that g, is going to be, actually, no, I'm going to call it f for our, hold on a second. Okay, I'm going to call it f for our first function. So our first function says we're going to pay 75% of the original price. So our first function is going to be 75 times our original price. Okay, my second function, my second sale, which I'm going to call s, just so we see that it's seconds. Again, I'm going to write this in terms of x. So whatever comes into s will be in terms of x, right? It doesn't need to be any particular price here. This is just a 10% sale, right? So that means we're going to pay 90%. So this is going to be 0.9 times x. So let's compose these. So my final product is going to be, I want to put my first function into my second function. So it's going to look like this. S of f of x. So that says do my, my first sale first, and then my second sale second. So the way I look at this is I actually look at the outside function first, which says 0.9x. So I'm going to write this as 0.9, and then whatever my input is. Well, the input is the entire other function, f of x. So I'm going to take the entire other function, 0.75x, and I'm going to put that inside of f. And now I'm actually going to do this multiplying of 0.9 times 0.75, which I'm going to do off camera here. So I get 0.675x is my composition, s of f of x. So what this is saying is, this is actually, if you think of this as 1 minus 0.675, This is actually what, 0.325. This is a 32.5% sale, not a 35% sale. So let's see this with some numbers here. I'm going to do part C in a moment here, but I want to start off actually with a $100 item so we can really see it nice and easy. So if I thought this was a 35% sale, then my $100 minus the 35%, that should be $65, right? Oops, not 65%, $65. Okay, but let's do this the other way. Let's do this the way that this actually reads. This says take your $100, right, and then subtract out 25%. So I'm going to do minus 25%. Well, that's $75. Okay, the next part says take another 10% off. What am I taking 10% off of? Well, I'm just taking 10% off of that $75. See how that happened here? Up here, I took the 35% off of the whole thing. But in my second scenario here, that second 10% just comes off the $75. So that's minus another $7.50. So that actually is going to be $67.50. So they're deliberately trying to do this to you, I'm sure. But if you're a little math savvy, you can actually see that you're actually not getting 35% off. You're getting like 32.5% off. Okay, so let's do this for the problem that's listed here. Let's see what a $60 item would be. Get this stuff out of the way. So I'm just going to use our composition that we have here. So if I want to find my sale price, I'm going to do S of F of 60. Right? So this is saying do 0.675 times 60. And when I do that, I get a total of $40.50. So I hope you found this useful. I hope you found this interesting. I know I did. This is one of my more interesting topics I think that we see all year. By the way, if you're interested in the other method, if you do all 35% off at one time, the price would be $39. So you might think you're getting that, but really you're paying $40.50 for this type of item. So take care, have a good day, and happy shopping to you out there.